हेलो स्टूडेंट्स, वेलकम बैक टू माय चैनल जिसका नाम है VS मैथ्स एकेडमी, मैथ्स इन अ वेरी सिंपल वे. So today I have come for you with a new topic to make it very simple, and that is, as you can see, logarithm of a complex number. So let me tell you, students, this is one of the very easy topic as exam point of view. Okay, it is very easy to prepare, it is very important for first year engineering students, as log of a complex number. Based on this, there will be a question of 6 marks, and this concept, if you learn, then you can even tackle the problems which are based on this concept, that is separate the complex number into real and imaginary parts. So based on this also 6 mark question or even more. So you can attempt this if you prepare this particular topic. So today we are going to have a very quick revision of this particular topic, so that if you are looking forward to revise it at the end moment of the examination, this is the perfect video that you have opened. So to start with, you need to know what is the definition of logarithm of a complex number. Okay, so we are going to start with the definition. I will tell you the definition in a very easy way. Okay, so let our complex number z, which we represent as x plus iy, or we can also write it as r cos theta plus ir sin theta, that is a polar representation, or we can also write it in the exponential as r e raised to I theta. Okay, I hope all of you know this very well. You know how to find out r and theta. If you don't know, then you can refer to our video, the video where I have covered roots of complex number. In that particular video I have covered how to find out this r and theta. Okay, so this conversion, if you know, then log of a complex number becomes very. So I will show you the log of complex number z. I will take it with r e raised to I theta exponential definition, because all of us know this very well, that log of a into b is log a plus log b, right? This all of us know, and hence we can also write, see here I wrote the support also. And now one more rule we know, that is what is log of a raised to b. So log of a raised to b is b log a. Using the same rule, I am going to write it as e raised to I theta log e. And students, as you know, log e is always 1, because it is log e to the base e. So it is 1. So we have log r plus I theta. So this is the definition of log z. That is what we have got. You can write it as log r e raised to I theta, or we can also write it as in terms of x plus iy. So what is log of x plus iy? So I can write it is log of, okay. What is r? So what is log r? R we know that it is root of x square plus y square. And what is theta? It is tan inverse of y by x. Okay, so we just need to replace this, and that's it. This raised to half, you can also write it like this, half log x square plus y square. So this is how you can write the definition of log very easily. You can remember it, or you can just make it on your own. There is no need for you to remember also, because this is very easy definition. So believe me, you just need to know this definition of logarithm to solve the problems from this topic, log of a complex number, and even to attempt questions from separate into real imaginary using complex number. So let's quickly now take the examples. Okay, before moving to example, I would like to tell you one more thing, that this value is called as, this is called a principal value of log. And if you want okay, it is not allowing. Okay, I'll write here. Okay, and then if you want, there is one more called as a general value. As you know, in the case of roots also, I told you what is general, meaning of general. So when you are taking the theta value as theta plus 2k pi of log, okay, general value of log represented as log. Okay, so it is theta is taken as theta plus 2k pi. You can write 2k pi, you can write 2n pi, whatever it is. Okay, theta as theta plus 2n pi. Okay, so this is how we write log. Okay, capital Z, you just need to write it as log r plus I theta plus 2n pi. Okay, this is called the general value of log. Now let's quickly move to the example. So students, here I have noted some standard examples, standard type of examples which are asked from this topic. So very quickly we will go through all these examples, solutions, and you will see that how easy it is to attempt all such type of questions once you know this definition of log which we have created here. Okay, I'm saying created because see, very easily I showed you how you can write the definition of log of z using its polar or exponential form. Okay, so see, if you know this exponential form of a complex number, then you can very easily write down the definition of log, and it is very easy to create on the spot. So you need not even remember, or you don't have to struggle much to remember the definition. So now let's proceed quickly to find out the solution to this problems. So solutions to the first problem. So it is the find log of, we have to find log of 1 plus I. Okay, so what we can do here, okay, 1 plus I, here 1 plus I, you can consider it as x plus iy. Okay, right, so we are having x is 1 and y is 1, like this you can note it down. And now we will follow the definition of log which is here. So we know that log of any complex number 1 plus I, that is x plus iy. Okay, how it is written, so here we have the definition above, it is half. Okay, I will keep like this so you can simultaneously watch both. So it is half log, just see I am writing from here, log you have to write x square plus y square, so it is 1 square plus 1 square plus I tan inverse of, okay, that is what we have to find out the theta. Okay, so it is 1 by 1. So we can complete this log as half log 2 plus I tan inverse 1 is pi by 4. Okay, so this is the value of log 1 plus I. See, very easily you can find out the answer. This is the answer of question number 1. It is done. So now we will proceed for solution to the problem 2. Okay, I'll just change the color. Okay, so we have to prove that log of 1 plus, okay, log of 1 plus I tan of alpha. Okay, we will start with this very easily. Again we will do here, if you note, in this case x is 1 and y is tan alpha. Okay, so it is half log, I'm using the definition again, it is x square plus y square. Now I know you cannot see it, but yes, now we know it by heart, so I'm using directly. So it is half square 1 square, that x square is 1 square, y square is tan square alpha plus I tan inverse of y by x. So y is tan alpha upon x is 1. So here, because we have x is 1 and y is tan alpha, so here we can write log of 1 plus tan square theta is sec square theta, that is x square alpha, plus this is I tan inverse of tan alpha, we can write it as just tan alpha, sorry, just alpha, and half, see, log of sec square, okay, half log of sec square, it is log, you can take this log sec square, you can write it as 2 log sec alpha plus I alpha. So do you see that we are getting the answer as it is log sec alpha plus I alpha. This is what we have been told to prove. If you see the question here, okay, prove that. So we have proved. So this way the answer is done. Okay, second question also very easily. We will quickly proceed to the solution to the third. So third question is separate into real imaginary I raised to I. So solution to the third problem. See how we will have to do. Let z equal to, we will consider it as I raised to I. Okay, so we have to find this as x plus iy. Okay, what it is, separate into real imaginary. So how we are going to approach this problem is, we will take log of z and we will find the answer, and at the end take log, and at the end take antilog. Okay, so this is the idea, that first we will take the log of a complex number and then solve it, and at the end to get the z we will take the antilog. So this is the idea to be used. Okay, here this is the idea to be used. So let's very quickly find it. So here let z as I raised to I, take log on both sides. So when we take log on both sides, it is log z equal to log of I raised to I. It can be written as I log I. Okay, so now we will focus on log I. What is log I? So this I will keep aside. I will apply definition to log I. So in case of I, see, if we write it as x plus iy, it is 0 plus 1 I. Okay, so this is x and this is y, right? So it will be log of I will be half log of x square plus y square, that is 0 square plus 1 square, okay, plus I tan inverse of y by x. So it is 1 by 0, tan inverse 1 by 0, right? So this is I half log 1. What is log 1? Log 1 is 0, but I will put it in the next line. I, what is tan inverse of? This is infinity. You know what is tan inverse of infinity? It is pi by 2. So we will get answer here as half log 1 is 0 plus I pi by 2. So actually we are getting it as I pi by 2. So it is minus of pi by 2. So we are getting that log z is actually minus of pi by 2. So last step is taking anti-log. So see, we are done actually with the answer very easily. Taking anti-log, we get z is equal to e raised to minus pi by 2, and that is what is the answer. So if you compare it as x plus iy, okay, or I'll not write xy, you may get confused. I will write a plus ib. So what is the real part? So if I say a plus ib, real part a is e raised to minus pi by 2. And what is imaginary part? So imaginary part b is 0, because there is no imaginary part in this. So this is how very easily you can attain the solution for separate into real and imaginary. Nothing special about I raised to I took this problem because this is very standard problem, but you on similar lines you can do, even you can solve I raised to my 1 plus I raised to I you can do, or any problem you can do, minus I raised to minus I, or you will see different problems are there in the book, or any given problem you can solve. Okay, any x plus iy raised to a plus ib you can solve. Okay, so next we will go for the solution of the last problem. So see, our last problem was finding general value log 1 plus I, log 1 minus I. So solution to this, here you can see that it is written as capital L. So let's write log of 1 plus I first. So what is the difference? General log, we have to write theta plus 2k pi, that's all. So we will start with half log of x square plus y square, that is 1 square plus 1 square. Here x is 1, y is also 1, plus I tan inverse of 1 by 1 plus 2n pi. Okay, you have to add 2n pi because it is general value. General value of theta, and hence general value of log. So here what we get is, it is half log 2 plus I tan inverse, it is pi by 4, tan inverse 1 just now we saw, plus 2n pi. Like this you have to write. This is log of 1 plus I. Similarly, you can just write the log of 1 minus I. What it will be? It is half log 2. What will be the difference? Only in between you will get it as minus, okay, because here minus, tan inverse will be minus. So minus, you can put it like this, and pi by 4 plus 2n pi. Okay, so you can write very easily like this, and now you can add equation 1 and 2, and so 1 plus 2 gives log of, I'll just see 1 and 2, this will get cancelled, and you will get 2 by 2 log 2, that is just log 2. So that's all. This is the answer, and you must have seen how easily we could find out. Okay, so like this we have answered all these 4 questions which I noted here, and all the questions you get in the exams will be similar, so very easily you can attempt them. Okay, like this, if you want to get revision of other topics also, we are having videos on our site VS Maths Academy, so please subscribe to our channel and press bell icon so that you will get notification for all the topics videos which we are uploading time to time. You can refer it for semester 1, 2, 3, 4. Okay, for all semester mathematics the videos are available, so be with us and don't miss the videos on other topics. There are videos on other topics of semester maths 1, for semester maths 1 examination. So all the best, do well and keep making maths very simple with us. Keep learning maths in a simple way with